Hello again. We are continuing our discussion of derivatives by talking about a specific application to derivatives, and that is finding the tangent lines and normal lines to a given curve. So let's get started. There's two important things that you need to know. When the tangent touches the line, when the tangent line touches the curve, then the y-coordinates are equal, but not only that, the slopes are equal. So the slope of the curve and the slope of that tangent line are going to be equal at that point. And when the normal line touches the curve, two things match up. The y-coordinates are equal, but the slopes are actually perpendicular. They are not the same. So we need to know those things about tangent lines and normal lines. So here are the steps that I will follow. If I have a function and the x-coordinate for the point of tangency, I'm going to plug x into f of x to get the y-coordinate that I'm interested in, and then I'm going to find the derivative. I'm going to plug the x that I was given into the derivative, and I'm going to get the derivative at that point. So if it's a tangent, I'm going to use the derivative as the slope, but if I'm looking for the slope of a normal line, I'm going to use the opposite reciprocal of that value to get the slope of the normal line. Okay, so let's look at an example of each. I need to find the tangent, the actual equation of the tangent line, to y equals x squared minus 2x plus 1 at x equals 2. So the y-coordinate, I just plug x into the function I was given, and I get that the y-coordinate is 1 at that point. The derivative of the function I was given is simply 2x minus 2, but at x equals 2, the derivative is worth 2. So that means that the slope of the tangent line is 2. So what I have is I have an x-coordinate, I have a y-coordinate, and I have a slope. So I have everything I need to write the equation of a line. So I'm going to use that slope of 2 instead of changing it, and my equation is going to be y minus 1 equals 2 times x minus 2, and there's the line right there. Okay, so you can see that it does touch the curve at x equals 1, and it does so in a way that is tangent to the curve. Okay, now let's do an example of a normal line. I need to find the normal to y equals x squared minus 2x plus 1, same function, at x equals negative 1. So you see the point right there on the curve. Let's figure out the y value of that point. Plugging in negative 1 into the function gives me 4. So I know that the y-coordinate is going to be 4. The derivative, again, is 2x minus 2. At negative 1, the derivative is negative 4. So that would be the slope of the tangent line. I'm looking for the slope of the normal line, which is perpendicular. So that means I will use, instead of a slope of negative 4, I'll use a slope of positive 1/4. So now I have everything I need. I have the x-coordinate, the y-coordinate, and the slope. So my equation is y minus 4 equals 1/4 times x plus 1. All right, and that is tangents and normals. If you have any questions, please let me know, and I will see you tomorrow.